Good morning, good afternoon, everybody. My name is Guy. I'm one of the solution architects here at Satori. I'm going to talk to you today about data access control with this hybrid multi-cloud conversation we're talking about. So I want to give you a little background on why Satori was founded and then dive into how we do what we do, maybe do a little demo and talk about some architecture and how this can empower the multi-cloud, hybrid multi-cloud conversation. So a little background in his previous role, our CTO was a product owner for a bunch of data and analytics platform. And what this meant is he had a huge amount of valuable data stored across a ton of different cloud providers. And with the advent of this data, the company that he was working with was trying to monetize this, right? How can we take the data that we own, turn it into business products? How can we take the data that we own, empower our BI platforms, our engineers, our developers to use it more securely? The catch that he came across pretty quickly was that each one of these data platforms, whether they're native to the cloud, whether they're data warehouses or new data lake technologies, each have different compliance constraints, and the number of systems that he had to keep managing for data was different. Now, the problem with that is that as a data engineer or a security engineer, you now have to manage and control access to a bunch of different platforms. You have to learn a bunch of different processes, and you have to learn a bunch of different languages for how to implement all of these different security controls. Obviously creates a lot of headache, but this brought to what we have as Satori today. Satori today is a system that allows for a single point of access to all of your cloud and on-prem data storage. So what does this look like? Essentially, any of these cloud-hosted databases, and you think about Redshift or Synapse or BigQuery, all supported, as well as your legacy environments like SQL, as well as some of the new next-gen technologies that we're seeing from Snowflake, Databricks, and even some of the filed-based objects that you've heard on the call today. Satori acts as the access layer to all of these databases. Easy way to think about Satori is a database CDN. Instead of accessing the database directly, users access Satori. Satori then proxies that connection downstream to the user. The reason this is a significantly better approach is I can almost guarantee the companies that you're supporting have at least 2, 3, 4, 5 different data stores where you're storing either structured or unstructured or even semi-structured data. And that means that your engineering teams are managing different control processes. So taking the bearing of access control and access enforcement off of the database means that a singular platform can unify the capabilities of the best features of each of these storage backends and provide them as a service as a front end. So instead of focusing on time to data or how long and how secure your data has to be, implementing this front end allows for a beautiful revenue generating data product that really cuts down on the time it takes to gain access to data. There's obviously some side benefits of these modernized data approaches, things like allowing us to store data at scale or internal operations, but security, governance, even data quality remains an open question. And even more on top of that, we start thinking about the ungovernedness of these data, right? So if a security engineer leaves and they were managing access to a particular platform, we have access to projects that ended years ago, or someone forgot to change the Active Directory role, or someone asked for a copy of what Guy had and got more permissions than they really need. What this leads to is an insecure access pattern, and it's by no means a fault of the people who are implementing it. It's a fault of needing to store data in multiple places for cost savings, for performance, for different accesses and different mechanisms. And so what we propose is again this approach of centralizing where access to data exists, regardless of the back end, and even regardless of the front end. If you're using tools like dbeaver, Datagrip, or Azure Data Studio, like I'll show in my demo, you're using BI platforms like Tableau or Power BI or Looker, or even just hitting these with an API or an application. Access to data shouldn't be limited by where the data exists. It should be limited by what access you need as the user consuming that data. And so a quick case study on what this looks like, and we'll spend most of the time that I have and on the demo actually looking at the product, one of the reference customers that we like to reference is Innovator, particularly because they are a hybrid multi-cloud environment with large Redshift and Snowflake deployments in Amazon and even larger deployments in SQL Server and Postgres on Azure. So the Satori implementation for them has given them the ability to address their security, compliance, and governance challenges in this massive data lake that they're collecting across multiple different data platforms that all hosts sensitive information. And so what this allows us to do is create this approach that is appealing. Instead of re-architecting the data, instead of rethinking and reapplying these ever-changing compliance and security requirements, change them on the access layer, change them where data is being accessed, as opposed to enforcing them on a database that may or may not have the capabilities that these teams and push-down offices come in. So what does this look like in product? Architecturally speaking, Satori sits between those conversations, whether it's a consumer using a tool like a database standard SQL editor or a BI platform, or like I said, even applications and APIs. Instead of accessing the database directly, they access a local Kubernetes cluster where the data exists. So if you're an Azure consumer, think AKS. If you're GCP, think GKE. If you're AWS, think EKS. And the fun part is you can deploy these across all of those cloud containers to create a unified approach, regardless of what or how many clouds you're currently using. And that's the beauty of this approach. Offload the permissions requirements, the security enforcements, the auditing capabilities of each of these systems into a smarter approach that can give unified control, unified access, and the same experience of the best of each of these, even when the downstream database doesn't give you those types of capabilities. What the product looks like from a deployment perspective, it's super simple. Starts by telling the Satori product about where this data exists. Here is my Postgres server, here is my Snowflake environment, here's my BigQuery, here's my Redshift, here's my Synapse, here's my Cockroach. Satori will automatically create a new enforcement link for those users to connect to. This doesn't mean any changes to credentials, no new usernames or passwords to use, no tokens to regenerate, no API keys to recreate. It's a simple modification of the connection string used by those tools to something that's hosted by that Kubernetes cluster. And so we create these access patterns across a number of different data stores. So I've created a data set example, a secure data set across a multi-cloud tenant that's granting my user access to a bunch of different locations. I'm gaining access to Postgres on both my AWS and GCP accounts. I'm gaining access to a particular table inside my SQL service. We don't have to grant access holistically. It can be very granular. And this means we can do things like exceptions as well. So instead of maybe the entire Postgres environment, I create exception rules where this project, this data mesh of devices gets access to subsets of data within that environment. On top of this different multi-dimensional access pattern, Satori also gives the user the ability to enforce different security policies. These can be compliance reporting policies where if an audit entry exceeds a certain number of returned rows, it flags an alert. These can be masking policies that enforce different data redaction or hashing rules. An example of what we do, anytime the data feeds through the system, we can create a masking profile that looks for sensitivity markers in the data, regardless of where the data is. If my SQL environment has address and I want to replace that, I don't have to create a rule on Azure SQL. If my AWS environment has emails in that data, I can redact that username from returning back to a particular user without changing the data in storage, right? I don't have to create these dynamic masking rules as they exist in that world. There's some additional benefits of this approach from a cataloging and compliance perspective. Every transaction we see through the network gets cataloged to where data exists. So if I want to, as a compliance officer, I want to see where data exists, where different tables contain different information, as well as what sensitivity markers exist within those tables. This unified approach of all the data traversing back through your Kubernetes clusters means that no matter where this data exists, the catalog stays up to date. masking can be enforced, and an audit trail that matches the environment, regardless of where it is, can now be consumed by auditors, by security teams. This can be forwarded to a SIM for alerting. And you can see an example of where this starts becoming very valuable, in that a standard audit across multiple data platforms gives you a really quick value on where data exists. So in this case, I granted my user access to a Postgres environment, the amount of time it took to pull the information, and any sensitivity data that was returned, as well as did Satori redact, mask, hash this data? Did we allow it through unaltered, unfiltered, or anything else? To show you how this works live, right? If I'm trying to pull information, the first thing I'm doing is connecting my environment to the Satori Cyber hostname. The credentials I'm using to connect to the database are the same credentials I would use otherwise. If I'm pulling data that I'm allowed to see, Satori will return that data. It'll return it masked. In this case, we had a redacting on the username, starring the address, and some other fields where we took a different action. But if I, as the user, try to access a different table within that same database, Satori will yell at me, right? Access to unauthorized data denied. Now, we have set this rule up where me as the user, or any user connecting to the database, can then potentially grant themselves access, right? There's a rule within that data, set called Guy self-service, where I've set up a rule to allow myself to request read-only access to this data. So that error that came back is a configuration that now allows users to grant themselves access if they meet certain criteria. But if I didn't have that rule in place, this would just say access unauthorized. Now, this error has never hit the database. This is not an error from the DB. The query has never hit the DB, but it is being logged as an attempt for a user to connect to the database. Now, if I go grab this URL, paste it in my browser, it'll populate, oh, request expired. Let's try it again. I go grab this URL again, paste it in the browser. Why is it expiring me? Oh, I know why. If I go grant myself access to this table, self-service read-only with the request pattern, and this can be an enforced request, whether it's a ticketing system, an ITSM number, something where we can log a request was being made. User goes, grants themselves access. It shows up in their available data set. And then if they go back and query the environment, a few seconds later, data returns, right? So this whole process takes no integration with Active Directory. It takes no re-architecting of the data. It's database agnostic. So whether it's Postgres on AWS or maybe Synapse on Azure Data Studio, all of that connection can flow directly through the mechanism that they're used to. It can be integrated through any API channel. So whether you're using an ITSM like ServiceNow or Jira, that can open a ticket and grant the user access. This requires no modification to the underlying database, right? So just to kind of recap what I'm talking about here, the hybrid multi-cloud data collection gives users the ability to store data correctly, right? Different databases are architected to store different data types more efficiently. And so when we have these multi-data locations, data can move fast and it can move quickly. Or when we start thinking about security and compliance rules, it can become a real pain. It can become a headache to manage access to this data and can become hindrances to the actual business efficiencies. It becomes a blocker to the data collection more so than an added, even though you're saving money and storing the data correctly. If we decouple access to data, the security enforcements of the data, the auditing of the data from the database, you can now use these cloud-hosted, self-hosted data lake approaches to what they're truly intended to do, speed up the time your users use when they get access to data. And so, if we kind of think about this, how fast this can implement, because there's no new authentication to create, there's new databases to create, there's no new caching layers to create. We can have a full deployment within a few weeks. Deploying the software is just as fast as your DevOps team can move. Actual implementation, very quick. We can have an entire environment configured and operational within a few hours. And we also offer training, as you would expect. And so, I'd say if you want to trial this out, if you want to test it, we do offer no cost POCs. There's a self-hosted model as well as a SaaS hosted model. If you're using only native cloud providers, I'd say give this a try. We're here to help. We're here to answer questions. Ron, I think that's all I got for you today.